So, in chapter 12, when you collect your data, then you made all those nice, beautiful pictures, right? Remember that time we made all the pictures?
No.
We made that one?
No.
And we made that one?
What was that? You do this on your own?
And we made this one? And I said, make a picture, make a picture, make a picture. Yeah. And did we make any other pictures? Oh, frequency. That's boring. Okay. So.
Yeah, I have no picture.
Okay. Maybe you missed that day. And you didn't watch. Maybe that's explains some things. All right. Anyway, there is one picture that is very, very nice, and it's when the histogram looks like that. And it doesn't have to be exactly that, okay? But it needs to be unimodal and symmetric. And if it's unimodal and nearly symmetric, doesn't have to be perfectly symmetric, but nearly symmetric, then something good is, okay? It is extremely useful, and it's called the normal model. However, sometimes histograms don't look like that. These types of histograms, you can actually put this curve on it. It won't be perfect, but it will be close. Or close enough for statisticians. Okay. So here's, they did that with that one. I'm sure, I guess that's close enough. All right. This one, if you'll notice, it looks like it's somebody's pulled on this tail. Okay. So what we call this one is skewed right, because the tail's been skewed to the right. Pulled. Okay. If that one's skewed right, then this one is skewed left. Well, look at you guys, advanced team. Okay. Those aren't very useful, but there are possibilities of this. Thanks, sir. Okay. So the one that's most useful is this normal model. All right. Attributes. What was I putting there? If I remembered, I would tell you, but I can't remember, so I guess I won't tell you. But it is unimodal, I'm sure. And it is symmetrical. And no gaps.
Skewed left and skewed right.
The mean is very close to the median. Can't think of anything else to say about it. Okay. And hopefully you will notice that if I have one of these things, and if you take statistics next semester, we're going to tell you something really cool about this normal model. Anyway, so here's the mean, right about here. Okay. And the further away you are from the mean, the less likely that happens. So if the mean is 10 and out here is 30, 30s don't happen very often. But neither do negative 20s. Okay, so the ones these things out here don't happen very often. Okay. We did standard deviation, right? And it's a way to measure spread, how far out they're spread. Okay. Well, there's something very interesting that happens with the normal model. It's on the next one. So if you have, you are 3 standard deviations above. It's better than being 3 standard deviations below. That's how you tell somebody that you love them. Okay. Now remember, there's a histogram behind this curve, but we're not showing you the histogram anymore. Okay, so we just turned that histogram into a curve. All right. So you got to remember that. This empirical rule, this is what we're going to talk about, and this takes a while, and it's somewhat, once you get it, it's easy. Until you get it, though, it's a little weird. Okay, it's also called the 68, 95, 99.7 rule. Oh. Davin, you look troubled. It's not good. It's not good at logarithms. Just one question? Oh, that happened. Yeah, there's one that's tricky. The last one? Yeah, it's a good one. That's to separate the high A's from the low A's right there. You should get everything else right.
The one plus the one?
Yeah.
Okay, yeah.
Yeah. All right. But you've got everything else done? You feel confident? Good. All right. So, here we go. Ready? If that X bar is the mean, these are standard deviations. So 1 standard deviation, 2 standard deviations, 3 standard deviations. How far you are from the mean, a standard deviation. Okay? So if I go 1 standard deviation to the left and 1 standard deviation to the right from the mean, then about 68% of the data lies within that. This is why most of you are just average in everything you do.
Thank you, Bert.
I'm sorry.
That motivates all of us.
No, you really are. It's like, I know your parents.
We're so average.
Your parents told you that you are special and you are wonderful and you are fantastic. However, for most things in this world, you're probably going to lie right in here. Your height, you're probably in the middle of the height, not Haven. Haven might be below here. Okay. Your intelligence, your athletic abilities, all this kind of stuff. However, what you're going to find is there's something in life that you're better than the normal. Okay. Now you're taking dual credit in high school, math. So I'm thinking you might already be over here. Okay. When you take the SAT.
That's what you get for thinking.
That's what you get for thinking. All right. So the SAT, most people, like right there in the middle, they just hit right in the middle. Guess what? Because they're just average. They're going to college. They're average college kids. Guess what? Colleges love average kids because they just come to class, make their grades, go on. They're fantastic. Okay. Now, if I go out, here's what's more amazing. If I go out another standard deviation, if I go to +2 standard deviations to -2 standard deviations, then I'm going to get 95. That's basically everyone. I mean, you're really, I guarantee you that your height is within the 2 standard deviations of the mean, even though you feel like, oh, I'm so short. It's like, nope, you're in the middle 95%, just like everybody else. No, I'm not. Are you over 5 foot tall?
Yes.
Oh. Are you?
Yes.
Are you?
Yes, Ferguson.
Okay. That's good. All
Barely,
right.
but I am.
All right. Now, okay. So here's one of the things.
With them, she said.
No, without them.
Here is one of the things in life that is on this. And like SAT scores in math. Do you know what the average or the mean is SAT scores in math?
450.
500. Do you know what the standard deviation is? 100. Almost exactly. All right, 600, 700. If I go out
I figured
One
it out, I think.
one standard deviation each way, there's more than one way to do that last problem. I can tell you that.
Okay.
So, all right, and I'm going to go 400, 300, 200. Okay? So, I would guess if you told me, hey, I took the SAT, well, I guess that your score is between 400 and 600. Unless I had you in class and go, oh, whoa, no, you're really, really good at math. I bet you're between 600 and 700. Or if you're really great at math, then you're between 700 and 800. Or if you're really poor at math, maybe you'll score down here. Okay. I used to be able to tell your abilities until last year. I have no idea if anybody has any abilities. Okay. Because I think last year was just figure it out. Okay. So here's the harder questions. What percent of people score from one standard deviation below to 2 standard deviations above the mean? So for the SATs, that would be from 400 to 700. What percent of kids figure are between 400 and 700? So I'm going to go making my picture. And I want to know from 400 to 700. Okay. I could draw a line right there because I know what this middle part is, isn't? Do you know what that middle part is?
That is the
68. Very good. Okay. So that's 68%. So what's this little part right here? Now this is how good you are at geometry right here, figuring this out. Oh, you can go do a calculator already. Good for you.
I'm probably good.
Nope. Most people have to use a calculator on this.
It's like 13.
No, tell me exact.
There.
Uh-huh.
13 and a half.
You see, you guys are smart.
Plus 68. 81.5.
Exactly. You got it? So this is 13 and a half. Now, did you get that, Haven?
Yes.
Okay. For the kids at home, tell me what you did. Did you go 95 minus 68 to get the area of these two darker shades,
Yep.
Yeah.
which was 30,
27.
oh, 27?
And then you divide it by 2.
Divide by 2, 13 and a half, 13 and a half. All right. So you did geometry. Fantastic.
I missed
Do you know what you really did? Calculus.
Calculus?
Calculus without calculus, yes.
I missed geometry. I did not. At this point, I do.
Okay.
With Mr. Manley.
All right. Now, part 2 of this. The empirical rule, there's a lot of good questions, okay? If you find one on your homework that's very, very difficult, let's talk about it. Okay. Now, there's another thing that we do with this. And we basically are going to measure you using standard deviation. Instead of, we're not measuring you in inches or seconds or anything else, we're going to measure you in standard deviations. Okay? So it is called a z-score. We're going to give you a z-score. Remember, statisticians are not very creative. So they come with a z-score. And it's basically this. Try not to sneeze into the microphone. Oh, I went to go watch a school burn down, so I got very runny nose. All right.
I was after batting cages.
So I would have take X, my value, my score, my raw score. Okay, and I'm going to subtract the mean.
Okay.
Okay. Now think about that. Think about that numerator for just a second. If I'm above the mean, I'm positive. If I'm below the mean, I'm negative. So your height is you're going to have a negative score, right? How tall are you?
5'7".
So I think the average woman is 5'6"
Yes.
or 5. 5'4". 5'4". So you're, yours would be
Right.
positive. Okay.
Really big inside.
Now, if your basketball team has a lot of negative z-scores, you're probably not going to be very good. It's just math. Just give me your z-scores of your math of your team, and I could tell you whether you're going to be good at it. All right, then we're going to take the denominator is the standard deviation. Many of these problems you will be able to do in your head. They're going to be that easy. Some of them you will need a calculator. When you do this in a calculator, do the numerator, hit enter, then hit divide by the denominator, unless you're going to stack the fraction. So watch that in these things. Okay. Women's shoe sizes are normally distributed with a mean size of 8. What size?
6.5.
6.5? 10. Okay. You're taller. Okay. And a standard deviation of 1. All right. What's the shoe size that is 1 standard deviation above the mean?
9.
9. So you see how easy? You don't have to use a formula or anything. The mean is 8. 1 standard deviation above the mean would be 9. 2 standard deviations above the mean would be 10. 2.5 standard deviations below the mean.
This is above.
That's it.
Oh, above the mean.
10.5.
10.5. Okay, piece of cake, right? What about one below?
Be a 7.
I don't know. Just thought maybe you all know something besides math.
You only teach us math.
I know, but this is like, I thought maybe you can't do math, so maybe you can do something else.
Can I read this out for them?
No, because this might be on their test too.
They're not animals.
Yeah, come on, don't you know
What
what?
in the world does an owl and an ape have in common?
They have
No,
eyeballs.
shh, nothing.
Eyeballs.
What's the group name for owls? That's what I'm asking.
Oh!
Shh, it's a test.
What?
If you have a if you have a bunch of owls, you have a blank of owls.
Oh.
You have a flock of owls. You don't have a flock of owls.
I don't remember what it was. I was just in my grandma's.
Wait, there's one for porcupine? You expect us to know one for
Some people have weird knowledge in their head. I'm trying to give them some buzz points.
I know,
right.
I know like some
I don't
of them,
have
but
that
not
kind of weird knowledge.
All right, here we go. Ready? 3.5 standards below the mean.
4.5. 5. 4.5.
I think I know one of these, and I don't even know if that's right.
Okay. All right.
That's a
Oh.
little foot.
Female heights in North America are approximately normally distributed, with a mean of 65 inches and a standard deviation of 3.5. Find the height that is 3 standard deviations above the mean.
Isn't 64 inches 5'5"?
It's 5'5".
That's what I said.
What's your answer?
I've seen how many inches it was.
So what's 3 standard deviations above the mean? Just
68. Oh, the standard deviation.
yeah. So this is a bad one because the standard deviation is 1.
We'll figure
But
it out. Here we go.
here's the standard deviation of 3.5. $75.5. That's what I got. Now that is 6'3.5".
Whoa.
How many girls in our school are 6'3.5"?
Probably like
One.
2.
0. I would say Nevaeh is the
Nevaeh
tallest girl.
and Addie.
I don't think she's 6'3".
Addie's pretty tall.
Who is?
Addie.
Addie's-
No, she's not that.
Okay, I didn't know she was taller.
6'3" girls are absolute tanks.
Yeah. All right, so
I've seen like a total of like maybe 2.
So if you want to go watch Division I girls volleyball or basketball, 6'5" is what they are, 6'3" to 6'5". All right, 2 standard deviations below the mean,
58.
58.
That's even.
But you're taller than 58, right?
Yes.
Okay, so ready? we can actually use this to figure out what your z-score is.
Oh,
I think that's the next page.
that's right.
Nope, not yet. Let's do it right now. I don't know when it shows up. Oh,
His comic strip.
I wasn't supposed to do z-scores yet. Okay, ready?
Great. Turn the page and you'll see this awesome.
All right, ready? So here's our make a picture part. We want to make a normal distribution. So draw the curve. Get used to drawing the curve. If you ask me for help on a homework and you don't have that, I'm not helping you. That's very good. Okay. In the middle is the mean, which is 70. Go out 3 standard deviations each way. And add 4 each time. Can we illustrate the empirical rule?
I suppose.
Come up 1 standard deviation each side. And that's 68%. Come up 2 standard deviations on each side. That's 95%. Come up 3 standard deviations on each side.
Mhm.
99.7 is almost everyone.
Where's the other point?
Ah, all right. So what's out way out here? How much is way out here? That's a good question. You see that? Because we went to 3. What's this right here? What percent is in there? 0.15%. Yeah, so that's 0.15. That is very few people, things are out there. So how much is over here? 0.15 over here as well. Okay, so what you did is you drew this next problem. Male height is 70. That's 5'10", with a standard deviation of 4 inches. How many are between 62 and 78? If you drew the picture right, 62. Boy, that line's right up there. Boom, boom. That's an easy one, right? Okay, so we've done the easy one. Now let's do the hard one. What percent are below 62%? Better than a 50?
It's way better than a 50, I think.
Alright.
I know I got confidence.
You feel confident?
I feel way better than the last one.
Okay, good.
I feel like I actually paid attention.
A bad test grade will do that to people. Alright.
I don't know if this is right. I got 2.5%.
Oh, you got 2.5%?
Yes.
What did you get? Because you've been on your phone. Off your phone. Alright, so we're going less than 62. So it's this part right here. You are correct. So there's 95% between these two. That means there's 5% that's not between those two. Split between 2 sides. So 2.5 and 2.5.
Plus
That includes the 0.15. Yeah. The hard part is what's between 58 and 62. You can do that. You can do 99.7 minus 95, then split that in half. So you got the concept of symmetry and splitting things in half. So you're in great shape. You've picked that up well. Okay, so new cars. Here we go. Nope, cars. Mean of 17, standard deviation of 500. Okay, so I'm going to make my little curve.
Oh, joy.
In the middle is 17,000. Oh, look at the math tips.
So,
It's like Haley sagging. Okay, it looks nothing like Haley.
Anybody know what 9 times 7 is?
A lot of people call it 63.
63.
9 times 7 is 6.
You looked in your calculator?
Yes. Yes, I did. Used to the 9 straight. What I just did.
Just 70 minus 7.
Or memorize it from 4th grade. Okay.
That too.
Fourth grader knows that.
All right, see what you know. All right, 16,500, 17,500. What's the answer,
What's a
Haley?
group of apes? Anyone here know?
I do.
Monkeys. That's what I put down. A game. And for a group of cockroaches, I put
68.
gross. Wait, I think that might actually be right.
Look at you go. Between 16,000 and 17,000. Hey, Haven. 16,000 and 17,000.
Cockroaches?
I don't know the answers. I have a book. I'm going to look them up.
So you expect us to know them?
I thought you might.
I
know
know
that
2 of them.
You know 2 of them?
Yeah.
That's good.
I don't know them.
And 0 of them? Yeah. Oh well. Hopefully everybody did so well they don't need bonus points.
Yep.
That didn't sound too confident to me.
Haven, still waiting on your score. Answer.
Still waiting on my score answer.
Yep.
I'm
What percent are between 16,000 and 17,000? Make the little graph. If you need to illustrate the empirical rule, go ahead and do that. You got an answer?
I said I don't get it either.
Okay. So these questions can get much more difficult.
Is it 47?
47 point what? 47.5? How did you get that? Did you go from here to here is 95? Isn't it? From 2 standard deviations each way is 95? And so half of 95 is 47 and a half?
Oh, no.
But you got the right answer.
I did?
Yeah?
Well, I still, because there's 17,000.
16,000.
Oh,
So it's,
I guess that would have been easier than what I did.
it's this. Yeah, there's, okay, so there's more than a way.
I went from, since I was 68 and it was in the middle of it, I divided 68 in half and
Okay.
then I did that
Did you
much.
calm down? No.
And add 13.5% to it. You got it.
That's how it worked in my head.
That's fine. It's fine. People do geometry in different manners. Okay. More than 17.5.
17,500.
That's not a good thing to not know how to do.
I don't know.
Is it 4.85?
14.5?
4.85.
4.85? How'd you get that?
Well, the 1750s and 90s.
So I'm gonna put it right here, and I'm interested in more than this, right?
I'm missing the part. But 99.7
Well,
minus 98.2.
18.2? All right. So I know right here, 50% is over on this side, right? So if I could figure out this side, I could subtract. If I could figure out what this little sliver is,
That's the
what's that little sliver?
What's the infinite dispute? Quarter of it.
I know from this line to the left is 50% over here. Okay, so I'm left with 50% left. So this section right here and what I'm actually interested together is 50%. So what is this little area right here?
That right there?
Mm-hmm.
34.
That's 34% right there.
How did you do that? Because that whole middle part is 68, so you divided by 2.
Okay, so just keep breaking things in half, you'll figure it out. Okay? So yeah, so that's 68. So
16%?
so 16% is the answer. Good job.
Trying to make it more complicated than it is.
Okay, so is this the last page? No, 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 we have 3 more.
We have time for it.
We actually, this is so easy. This is the z-score, which we've already introduced. So, and the z-score is equal to the data. Oh, your formula chart actually has something. They actually use words. Data item minus mean over standard deviation. Your height minus the mean height divided by the standard deviation height will give you a z-score.
My height.
What your
minus the mean.
What was your 5'7"? So you're 2 inches above the mean. So 5'7" minus 5'5" is 2. The standard deviation was 3.5. So it'd be 2 divided by 3.5, which is 4/7, which is about, you have a z-score of 0.52 or something like that. 5.6. Okay. So the higher the z-score, think about it. The higher, here's the mean. The higher the z-score, you're over here, right? And if it's negative, the bigger negatives are way out there. Okay. So what's the z-score for the mean? What the average height woman is 5'5". So what if you were exactly 5'5"? So what would your z-score be? This is important that you know this. 0. So it'd be 5 1/2 minus 5 1/2. No, it's 5'5", isn't it? Sorry, 5'5" minus 5'5" divided by 3.5, which means 0 over 3.5, which is 0. So the mean is always 0 z-score. That's on your. I think that's on your stinking final. Is that what's the z-score for the mean? Okay, so here we go. Normally distributed with a mean of 100, standard deviation of 8, and we're going to convert all these people into z-scores. We don't even know what we're measuring. So z would be 120 minus 100 divided by 8, which is 20 divided by 8, which is 2.5. Thank you. All right. Ready for the next one? Everybody okay with that? Piece of cake. Just a little simple math. 90 minus 100 divided by 8. Negative 10/8, which is negative 1.25. And this one's just the 100 minus 100 divided by 8. Nice easy one. Okay? Horse pregnancies. Remember, this is Weatherford College. They have a rodeo team, so we have to do horse pregnancy questions. 336 days. Horse is pregnant for almost a whole year. That's a long time. And look at the standard deviation, 3 days. It's not very big standard deviation, is it? Okay. So your horse is pregnant now for 342 days. What's his Z-score? What's your answer? What's your Z-score? Did you get a Z-score? 6/3, but a lot of kids these days are calling that 2.
Yeah.
Okay, do you understand what the next question might be? What percent of horses are pregnant for more than 342 days? So you do this, right? You come out here, and we're already 2 standard deviations out here, and then we see what that percent. So those are harder questions, and it's really our next class. I'm not sure if we get that in this class or not. Okay, 336. Well, that is the mean, right? So Z is equal to 0, and 333 days is a Z of negative 1. Negative 1. Make sure. Okay, be careful. There's really negative 1 and positive 1. As you do your homework, make sure you get those correct. Get that in your head. Are you above the mean or are you below the mean? Okay. Last thing. Yep. Okay. All right. Gotta figure out what goes in there.
We got time for you.
I don't know.
We ain't got time for you to think. You better just know it.
In 4 minutes. Go.
Okay. An interval
6, 7.
of confidence. Okay. All right. So instead of saying, "Hey, I think 30% are going to do this. I think 30% of the people are going to do this," they would say interval of confidence. That I'm pretty confident that between 25 and 35.
You should have been a doctor.
So they won't give you an exact number. They'll give you a range of numbers. Okay. So if we want to be 95% confident, which is very confident, okay? Weather forecasts are probably at 95% confident. That is a very standard confidence level, especially for this course, okay? Then all we have to do is use that formula right there, which is on your formula sheet. We got it. We just use that formula on your formula sheet, okay? You won't have to memorize it, to figure out how big the sample has to be or how wide the sample is going to be. All right. So let's say we've talked about 800 students, and 62% of them say that they struggle with showing up to class on time.
That's a big number.
All right. Ready? So we're going to go 1 over the square root of 800 times 100. So you got to do that in your calculator. 1 divided by, yeah. I don't like 100 and then add a percent sign. 1 divided by, where's the square root sign? Square root of 800. Boom. Which is 0.035 times 100. and I got 3.5. So the margin of error is 3.5%. All right, so what does that mean? So my interval is going to go from my mean minus my margin of error to my mean plus my margin of error. So I think that if 62% of them say that they're not going to be on time, then I can go 62 minus 3.5, which is 58.5%. And then I can add the margin of error to the mean, and I'd get 65.5%. And we just made ourselves a confidence interval. It is a weird concept because we're not going to say 62%. We're going to say, oh, somewhere between 58 and 65%. We are going to give us some wiggle room. Oh, one more question.
You have 30 seconds.
We got 30 seconds. Ready?
First.
4,000 people.
Oh.
Random sample of 4,000. Find the margin of error. 1 over the square root of 4,000 times 100. So 1 divided by square root of 4,000 times 100 is 1.58 is my margin of error.
Well,
Okay? So 60.2. So 60.2 minus 1.58 to 60.2 plus 1.58 will give you the margin of error. Tim, we got to finish up. Let's go. We've been working too long. We only got 2 class periods. Come on in. Come on. All right, we're done. That was the last of the
I
notes.
thought you said it would take 2 days.
That's it.
Look.